Okay, so this graph we're going to look at describing quadratic function graphs. Then we're going to look at a couple of different things about each one, domain, range, end behavior, and increasing and decreasing intervals. This is something we'll come back to a lot with other kinds of functions. We're going to start looking at it with quadratic functions. So first of all, here's my graph. Let's kind of look at it real carefully. We can see a couple things. One is that here's the vertex. It's at, what is that? 2, 1. It means that I've got a axis of symmetry. It runs right like through here at x equals 2. Alright, and it's upward facing. Okay, those are all things. They're kind of useful to know if you can just see it first. Okay, so what's the domain? Well, the good thing about domain is the domain of a quadratic function is always all real numbers, which we write as negative infinity to positive infinity, and always parentheses around infinity. The range. Well, if you look at the graph, and you can imagine this keeps going on forever up both sides. The range is everything in this graph is at x equals 1 or above. So we can kind of imagine a line like this runs through the graph, right across the bottom of the graph. Everything is here and up. So we'll write the range as it is everything from 1, right, because this is y equals 1, and up. So everything from 1 up to infinity. We use the square brackets here because we're including 1, because it does actually come down to 1, right? There's that point right there at 2, 1. Okay, so that's domain and range. End behavior tells me what's happening as I go way out in this direction towards positive infinity and way out in this direction towards negative infinity. Well, what's happening on this side? Just to describe what we could say, well, this graph, as I go out this way, the graph goes up and up and up. So it goes up towards positive infinity. I write that over here. That means that as x goes to positive infinity, right, x is going to positive infinity along here, getting bigger, and x is getting bigger, y is getting bigger. So as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y also goes to positive infinity. So either way, both sides, y is just getting bigger and bigger. So the farther I go out this way, towards negative infinity, y gets bigger and bigger, closer to infinity. Well, not closer to infinity, but bigger and bigger. You don't really get closer to infinity. Okay, anyway, increasing intervals. So there's two parts to this graph, right? There's a part on this left-hand side where the graph is decreasing. It's going down, down, down. And then over here it's going up, up, up. If you imagine you're on a ride, always going from left to right, you're going down, 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 right up to here. And then you start going up, 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 up. So the up, up, up is your increasing interval. It starts at x equals 2 and keeps going. So we write it like this. Open interval, so that it doesn't include 2, because at 2 we're not increasing or decreasing, we just sort of flattened out. But after that, from 2 to infinity, we're increasing. Round brackets on both, parentheses on both. The decreasing interval, that's our down, down, down part. So the down, down, down starts way out here at negative infinity and keeps going down, 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 all the way to 2, till x equals 2. So we're going to say negative infinity to 2. Alright, so that's our domain, range, end behavior, increasing interval, and decreasing interval. Let's look at another example. I'm going to go through this one a little faster. So here's my vertex. It's at negative 4, negative 3. So this is my axis of symmetry. My axis of symmetry is at x equals negative 4. And I can sort of say, here's the bottom of the graph. It's right here at y equals negative 3. And if I have all that, it makes this a lot easier. Well, the domain, always, for quadratic functions, is always negative infinity to infinity. The range, everything is from negative 3 up. So my range is negative 3 to infinity. And it includes negative 3 because it does get down to negative 3, so we have to put a square bracket there. What about the end behavior? As I go to the right, as x goes towards infinity, y gets bigger and bigger, right? So y is going towards infinity, positive infinity. As I go towards the left, x is still getting bigger, I mean, y is still getting bigger. Y is getting bigger and bigger, getting closer, but not closer, but getting bigger and bigger, so it's going towards positive infinity. Increasing interval, decreasing interval, let's look at this. Well, here we go down, 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 so we get to x equals -4. And then we go up, 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 up. So the up, 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 that's our increasing interval. It goes from -4 to infinity. Our decreasing interval, it starts way out here at -infinity. We go down, 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 down until we get there. So -infinity up to -4. That's a terrible infinity. Okay. So there we go. Let's look at one more. Not that one. Let's look at number 7 here. So the domain, so let's look at our vertex. Our vertex is here, is at 1, 5, which means that our axis of symmetry is at x equals 1. And the graph tops out here, all right, at y equals 5. Our domain, every time, -infinity to infinity. There will be graphs that don't have a domain of all real numbers, but we haven't gotten to any of those kinds of functions yet. Our range is, okay, now here the range is everything is from 5 below. So if we're thinking of it, we can think of it as it goes from -infinity all the way up to 5. So that's going to be our range. -infinity up to 5, and it includes 5, because it does actually get up to the y equals 5. So we'll put square brackets there. Now what's happening in the end behavior? Well, if we look at both sides, what's happening is you go out to the right, the function goes down and down towards -infinity. As you go out to the left, the function goes down, down towards -infinity. So both sides, the end behavior is, as x goes to positive infinity, y goes to -infinity. That's the right-hand side. As x goes to -infinity, that's the left-hand side, y is still going towards -infinity. You'll notice that with quadratic functions, the left-hand and the right-hand end behaviors are always going to be the same. Not true of every kind of function, but it is always true with quadratics. Okay, increasing interval. Well, this one, we go up, 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 all the way to x equals 1, and then we go down, 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 down. Remember, with the increasing and decreasing intervals, we're talking about what x values is the function increasing, and on what x values is the function decreasing. So the x values is from -infinity all the way up to 1. It's increasing, right? I'm going up, 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 up till I get to x equals 1. And then from 1 to positive infinity, I'm going down, 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 down. Okay? So that's how we find all the domain, range, end behavior, and increasing and decreasing intervals of a quadratic function.